Welcome back, Lancers. It's Mrs. Allen again, and I'm going to be presenting the next couple lessons to you about states of matter. You can see from the preview slide here, the title, a little bit about what we're going to be talking about. We're going to be concentrating on the three most common states of matter. There is a fourth one, which is over to the right over here. Neon signs, ionized gas. That is sometimes called plasma. And we're not really going to concentrate on it, but just so you know, if you ever look in the future, you might find that there are more than three states of matter. But we're going to be concentrating on these three most common types that you see right here. But before we get into that, we're going to do a little review about your lab that you went over with Ms. Longebach previously. So first of all, this is just showing what your data table should have looked like. And you should have filled your table and it should look like this. So you have the property, you have the liquid 1, 2, and 3, and then you would have written in your results here. So if you need to pause and check your data table against this one, please go ahead and do so. You notice I have the results marked out here, so you can't see that yet, but we will be going over those. So you found things about the odor, the melting point, the flammability, and then from that you used your resource and you were able to distinguish which was which. Okay, so next here are the results you should have come up with. After looking at all of that data and comparing it to your resource sheet, you should have found that liquid 1 was water, written H2O. Liquid 2 was vinegar, H3COOH. And liquid 3 was isopropyl alcohol, which is like rubbing alcohol, C3H8O. And liquid 4 was hydrogen peroxide, which is H2O2. So take a moment and check your results. If you didn't quite get it right, then you can fix those and think about what it is that maybe got mixed up. And finally, you were to write a conclusion. So a conclusion is where you get your data, you get your results, and then you just talk about your findings. So Mrs. Longebach wrote this conclusion. Yours should be similar to it, but it's not going to be word for word. She writes, solubility, odor, and melting point are all physical properties. We can observe each of them without having to facilitate a chemical reaction. Flammability is a chemical property because we are observing a change in substance caused by chemical reaction. In this case, adding heat and oxygen, then observing the result. So that might be an example of something you would have written for your conclusion. So again, just check that and pause if you need to, and then we'll go on to the rest of today's lesson. Okay, so like I said, we're going to talk about the three most common states of matter, and they are solids, liquids, and gases. Move myself out of the way a little. And I just have different examples here. You can see for solid, I have an ice block and some rocks. For liquids, I have water and pouring coffee or tea. And then for gas, we have some water vapor here, both in different forms, natural water vapor and then that from a boiling pot. Okay, so let's talk about the first one. First, we have solids. Examples would be all kinds of things. You guys know these. Skyscraper, a grain of sand, a blade of grass, a strand of hair. So you can see they can be big, they can be small, they can be soft, they can be hard, but they are all solids. And the reason they're solids is because of these properties. They have a fixed shape, they have a fixed volume, and the atoms that make it up are closely compacted and cannot move away from each other. So here are some examples again. So here you have ice cubes in a glass. So both the ice cubes are a solid and the glass is a solid. So it has a fixed shape. The shape of the glass doesn't change. It has a fixed volume. It takes up the same amount of space always. And then here we have an example of what the molecules would look like in a solid. So here they are. They're very compacted. They are in a definite rigid shape, and they are in a definite fixed volume. So they're taking up the same amount of space and keeping their shape no matter what you put them in. And that'll make a little more sense later when we talk about the next ones. But for now, I'd like you to go ahead and get your notebooks out if you don't already have them. And you're going to add in another definition on your words of chemistry. So here we go. You can pause it to write this down. A solid is a state of matter that has a fixed shape and volume where the atoms have low kinetic energy and are tightly held together. And I would suggest drawing that picture as well. And then when you're ready, you can move on to the next one. So now we're going to talk about liquids. So examples of liquids: water, milk, blood, a milkshake. Those are all common things that you guys, I'm sure, would know are a liquid. But properties of liquid and why they're liquids is what we're going to get into here. So they have no fixed shape. They take on the shape of their container. So if you have any of those things like water or milk or blood or a milkshake, and you pour it into a container, it's going to take on the shape of that container. So if you look down here at these 3 different containers, I have a beaker, an Erlenmeyer flask, and a measuring cylinder. And as you can see, the amount of liquid in each of them is 100 milliliters, but it might look different in different shaped containers. Next property is it does have a fixed volume. So it's like we were saying, even though the shape is different, the amount stays the same. So whether you pour it into any kind of container, you're going to have the same amount of liquid. And this one, the molecules are loosely held together. They can flow freely around each other. They have weak attractive forces between them. And you can see that from this picture. So they're not rigid. There's no fixed shape, but they do have a fixed volume. So you're going to go ahead and add that to your words of chemistry on page C2. This is number 13. I'll move myself so you can see that. So a liquid is a state of matter that takes the shape of its container and keeps a fixed volume. The atoms are loosely held together, they can flow freely around each other, and they have a moderate amount of kinetic energy. That means the molecules are moving faster than a solid. So let's watch this. So you see the liquid pouring from one container into another. It's keeping the same volume, but it's changing the shape because it's going into a different container. So gases, examples of gases are oxygen, carbon dioxide, helium, air, water vapor. It's kind of a misnomer when we say we're going to go get gas into our car, because that's actually a liquid that we're putting into our car. So gases are something that are suspended in the air. Okay, so all of these things that we talked about are what we breathe in and out, what we fill a balloon with, and even this water vapor here that you see coming out of this geyser. So properties of gases are there's no fixed shape, no fixed volume, and the molecules in gases can move freely apart from each other in random motion and are not held together. And they have a lot of kinetic energy. So you can see that in these 2 different pictures I have here. So here's the molecules of gases. They are not rigid, there is no fixed shape, and there's no fixed volume. They can take up as much space as you give them. And here's an example of the energy that is in gas. So you can see here that this container, the temperature is medium or low, and the gas is moving, but as you increase the temperature, the gas particles move faster and faster. So here's your next definition that you're going to put onto that page, C2. You may be onto C3 by now, and that is number 14. So gas, a state of matter where the particles can flow freely. They take the shape and volume of their container. The atoms have a high amount of kinetic energy, and they're not held together. They move around quickly and randomly. And that's example is in this picture, which you should also draw in your notebook. So take a moment, write that in, and then join back in when you're ready. So now I'm just going to show you an example of all of these types of matter. It shows, this is a great demo, so let's just watch it. So we're going to start with a solid. And so here we have some ice cubes, and you can see that the molecules in the ice cubes are there. And if you look closely at them, they are not just still. They're still moving around. Molecules are always moving, but they're vibrating and they're really stuck together tightly. Their attractive forces are tight between these things. And if we move it from one container to another, we can see that the ice cubes are still going to contain their same shape that they had. They're going to still take up the same amount of space that they had. And the molecules are still going to be vibrating. Now, if we change it to be looking at water instead, so now we see those water molecules and their kinetic energy is increased, which means they're moving around, they're flowing around each other. And if we move this liquid from one container to another, I'm sure you can see that they are still going to contain the same amount of volume, but now it's going to have a different shape because this rectangle is a different shape than the glass that we poured it out of. And then finally, we're going to move on to gas. So here we have these molecules are moving around really fast. They're not attracted to each other anymore. And if we decide to try to pour the gas from this container into the rectangle, let's see what happens. So if we remove the lid, we can see that those are not going to go into the container. They're just going to fly out into the atmosphere and spread as far apart from each other as whatever random motion takes them. So they don't have a fixed shape, they don't have a fixed volume, and they're no longer attracted to each other. Okay, we have a form for you to fill out today to test your understanding on this. If you need to come back and look at the video again, that's perfectly fine. And I hope you have a great day, and I'll see you again tomorrow.